Hello, my name is Bjørnfis, and I have chosen iron. In this presentation, I would like to talk about iron, the periodic table, shell model, isotopes, the state of matter, chemical equation, reactant product, and at last daily use. First, we have Fe, which is iron, which stands for ferrum in Latin. Then we have the number of protons, which is the same number as the element, and that's 26 in the periodic table. Then we have the neutrons, and the neutrons can vary after the number of nuclei the element have, and in iron it could be 55 or 56. So it will always. So if we look at the A, Z, and N, A, Z plus N, A is the number of nucleons, which is 55 or 56. Then we have the Z, which stands for the atomic number of the protons, which is 26, and then we have the number of neutrons, which is N, and that can vary for 29 and 30. Then we have the atomic mass, which is iron's atomic mass has 55.845. Then we have the periodic table, and it's in group 8, which we see from over first to 8, and then we go down, and it's number 26, which is ferrum. It's iron, Fe, and that's the group, which is called the iron group. Then we have the down, which is the period, and it's in the 4th period, so we go down to 4 and over to Fe, and meaning it's in the 4th period, is that it has 4 shells in its shell model. It's a transition metal, which when a element can form more than one type of ion, it's a transitioning metal, and they are often known by the high state of matter, which is the boiling point and the melting point. They are very strong and hard, and they are less reactive without O2 and H2O. And in this example, we have iron, which can give 2 plus. Because they have 2 electrons to give away, so it will give 2 plus atomic ions, but it can also give 3 plus atomic ions because they have an extra isotope. So it can either be iron 2 ions, iron 3 ions. And here we have the shell model, which is also called the electron shell. If we look up here, we see 26 is the iron again, and then we have the electrons in each shell, which is 2, 8, 14, and 2. And if you plus all of these together, it would give 26, which is the number of iron. So in the first shell we have 2, which is maximum, and that's called the inner shell. Then we have the number 2 shell, which I call the middle shell, and it has 8, which is also the maximum. Then we have the other middle shell, which is the 3rd shell, and it has 14 electrons. And then we have the outer shell, which has 2 electrons. And of course, iron would like to follow the octet rule, which means that it would like to have the maximum number of electrons in the outer shell, and because they want to look like a noble gas. But iron gives 2 electrons from the outer shell to another to a gas, because or non-metal, and then it will follow the octet rule, then it would have 24 electrons, but it would still be iron, but it would look like chromium now. Yes, and iron have 27 isotopes, and iron is number 26, so it means that it have 1 plus isotope, and that means that it can give another one to there, so it can be plus the atomic ion as said earlier. Isotopes are atoms with the same number of protons, but it have a different number of neutrons. And if you said in other words, they have a different atomic weight, all of them. Yes, and the isotopes are different an isotope is a different form of a single element, and that depends on the weight, as said earlier. The iron have 4 stable isotopes and 23 unstable isotopes. Then we have the state of matter of iron, and the state of matter is the melting and boiling point. Iron is melting at 1530 38 degrees Celsius, and from there it's a solid, and then it becomes a liquid, and it's boiling at 2,862 degrees Celsius, and from there it's a liquid which becomes a gas. Yes. And if we just get back here, because I just forgot to say something. When I said the number of nucleons could be 55 or 56, then I didn't say which was more common, and it's the most common one of those two is 56, and it's because 56 is closer to the average weight, which is 55.545. So that's the most common one to find in nature. Then we have the chemical equation, the reactant, and the product. This is the chemical equation, and rust forms when iron reacts with O2 and H2O. Iron, and that's the same as iron plus oxygen plus water, gives rust. Then we have in the reactant, it's 4Fe plus 2H2O plus 3O2, which is 4 iron, 2 H2O, and plus 3 oxygens. And then it gives the product, which is 2Fe2O3 multiplied by H2O. And it's the reason why it stands like it's multiplied. It's because the Fe2O3 is a crystal or atom, and a crystal, and the H2O is like inside of that crystal, so it's multiplied. So it's inside of the crystal, and that's the reaction of the product. And here I have a little video that shows the how it is. And first here we see a nail, and let's take a second. Yeah. Here we have a nail, and when it's combined with the O2, which should appear here, and the H2O, it will rust. And this process will take a lot of time, so don't count it being done quickly. Here we have the nail, but now it's all brown and rusty. Combines with these two, because it combines with the O2 and the water. So here, for example, we have a car. It could be a bicycle, just something made with iron. And for preventing this iron to rust, we paint it. And this paint is like a prevention for rust, so it would make sure that the iron doesn't get hit by the or get involved with the O2 and the H2O. So here we see how that happens, and yeah, here we have the O2 and the water and the metal, which is iron, and that's just how it is in the nature. And if you're in a very humid environment, this process would take a lot less time. It would take quicker. And here we have the equation again, which now we have the name. So it's iron plus oxygen plus water, which becomes hydrated iron 3 oxide, which is rust. Yeah, and that's about it for that. Now to the daily use, and it's used in cars, planes, bicycles, pots and pans, and all that kind of stuff. It's also in your blood, which is and it's very important for blood actually. The iron is the iron does that your oxygen is getting transported around in your body. So without the iron in your blood, you would die. So you can say the iron is responsible for your living, and it's responsible for the oxygen. It's responsible for the oxygen to get for the oxygen to move around in your body. Yeah, and that's my presentation.